Imagine a moment in time when everything we know, everything we see, and even things we can't see, were all crammed into a single point. Yes, that's the beginning we're talking about. That, my friends, is the grand opening of the universe, the Big Bang. Though the term Big Bang might suggest an explosion, scientists believe it was more of a rapid expansion, a stretching out of space from a single infinitesimally small point. In a fraction of a second, our universe grew from smaller than the head of a pin to something astronomical in size, and it hasn't stopped growing since. This is not just a story, but the prevailing cosmological model that explains the observable phenomena of our universe. It's a theory supported by a vast amount of scientific evidence, from the large-scale distribution of galaxies to the tiniest particles of matter. The Big Bang theory posits that all matter, all space, everything, originated from a single point, a singularity. This singularity was incredibly hot and dense, and it began to expand around 13.8 billion years ago. As it expanded, it cooled, leading to the formation of atoms, stars, and eventually galaxies. Science isn't about accepting things on faith. It's about questioning, exploring, and understanding the world around us. And the Big Bang theory is no exception. It's a theory that has been rigorously tested, debated, and refined over the decades. But why should we care about something that happened billions of years ago? Well, the Big Bang isn't just about the past. It's about the here and now. The universe as we know it, the stars, the galaxies, the vast cosmic web, owes its existence to the Big Bang. It's the origin story of everything and provides a framework for understanding the universe and our place in it. So, the Big Bang isn't just a theory about the past, it's the key to understanding our present and future. The name Big Bang might conjure up images of a colossal explosion, but it's not about an explosion in space. Now let's unpack that name a little bit. You see, when we talk about the Big Bang, we're not referring to a traditional explosion like the kind you might see in a blockbuster movie. Instead, the Big Bang is all about expansion. Imagine a balloon inflating, stretching in all directions from every point on its surface. That's a closer analogy to what happened during the Big Bang. The universe didn't explode into existence. It expanded from an incredibly dense and hot state. And this expansion didn't occur within space. Rather, space itself was, and still is, part of this vast cosmic expansion. To put it simply, it's not just that things are moving in space, but space itself is growing. The term Big Bang was coined by British astronomer Fred Hoyle, and interestingly enough, he meant it somewhat facetiously. Hoyle was a proponent of the steady-state theory of the universe, a rival concept to the Big Bang theory. During a radio broadcast in 1949, Hoyle used the term Big Bang in a dismissive way. However, the name stuck around and has been used ever since to describe the universe's early rapid expansion. So the next time you think of the Big Bang, don't imagine a fiery explosion hurling matter into the void. Instead, picture the entire universe, every galaxy, star, and atom embedded in the fabric of space, all of it stretching and growing over billions of years. The Big Bang isn't an event that happened at some distant point in the universe. It's a process, a transformation that's been unfolding for over 13 billion years and continues to this very day. Remember, it's not about an explosion blowing things into space, it's about space itself growing and stretching. If we could rewind the cosmic clock, what would we see? This is where our cosmic journey takes a thrilling turn. Let's journey back through time, to the very beginning of the universe. Our journey starts at a point of unimaginable density and temperature, known as the primordial singularity. This is the time zero, the moment of the Big Bang itself. From this singularity, the universe began to expand rapidly, a process known as cosmic inflation. In a fraction of a second, the universe grew from smaller than an atom to the size of a marble. In these early moments, the universe was a hot, dense soup of particles, too hot and energetic for atoms to form. As the universe continued to expand and cool, we reach a key moment in our timeline, roughly 3 minutes after the Big Bang. This is the epoch of nucleosynthesis, when the universe cooled enough for atomic nuclei to form. Hydrogen and helium, the simplest and lightest elements, were created during this stage. Fast forward to around 375,000 years after the Big Bang, and we reach another pivotal moment. The universe had cooled enough for electrons to bind with atomic nuclei to form neutral atoms. This resulted in the cosmic microwave background radiation, a faint glow that permeates the universe and is one of the key pieces of evidence for the Big Bang. Finally, a billion years after the Big Bang, the universe entered the epoch of reionization. This is when the first stars and galaxies formed, lighting up the universe for the first time. This cosmic timeline is a testament to the power of scientific inquiry. From a single point of unimaginable density, the universe has expanded and evolved into the vast, complex cosmos we see today. Each stage in the universe's history has left its mark, from the light elements created during nucleosynthesis, to the cosmic microwave background radiation, to the stars and galaxies we see in the night sky. Just like a film reel, the universe has its own thrilling story to tell. The Big Bang isn't just a grand idea, it's supported by tangible evidence. One of the most compelling pieces of evidence for the Big Bang is the redshift of galaxies. When we look at distant galaxies, we see that their light is shifted towards the red end of the spectrum. This is known as redshift, but why does it happen? Imagine the sound of a siren as it moves away from you. It sounds lower, right? That's because the waves are stretched out. The same thing happens with light. As a galaxy moves away from us, its light waves are stretched out, making them look more red. This redshift is evidence that the universe is expanding, and if we trace that expansion back in time, we arrive at the Big Bang. Another major piece of evidence is the cosmic microwave background radiation, or CMB for short. This is the afterglow of the Big Bang, a faint whisper of light that fills the entire universe. It's incredibly uniform, with tiny fluctuations that match the predictions of the Big Bang theory remarkably well. This radiation was first detected by accident in the mid-20th century and has been studied in detail ever since. It's like the universe's baby picture, showing us what things looked like just a few 100,000 years after the Big Bang. These two pieces of evidence, the redshift of galaxies and the cosmic microwave background radiation, are crucial pillars supporting the Big Bang theory. They tell us that the universe is expanding and that it was once much hotter and denser than it is today. However, it's important to remember that science is always evolving. New data could revise our understanding of the Big Bang or even replace it with a different theory. But for now, the Big Bang theory is the best explanation we have for the origins of our universe. So the universe has left us clues about its birth, if we know where to look. The Big Bang isn't just about galaxies and cosmic radiation. It's about you and me. It's about the air we breathe, the water we drink, and the food we eat. It's about the very fabric of our existence. You see, the Big Bang didn't just give birth to galaxies and stars. It also birthed the elements that make up everything we see, touch, taste, and feel. The hydrogen in the water you drink, the oxygen you breathe, the carbon in your DNA, and the iron in your blood were all created during the incredible heat of the Big Bang and later in the hearts of stars. So when you look up at the night sky, you're not just seeing distant stars and galaxies. You're seeing your distant relatives. You're seeing the cosmic forge where the elements that make up your body were created. Every time you take a breath, you're breathing in atoms that were once part of a star. Every time you drink a glass of water, you're sipping on the remnants of the Big Bang. Every time you eat a meal, you're consuming elements that were forged in the fiery hearts of stars. So remember, the next time you look up at the night sky, you're not just looking at distant stars and galaxies. You're looking at your family, you're looking at yourself. We are, in a very real sense, children of the cosmos. The Big Bang is truly a marvel of the universe. It's an awe-inspiring concept, the inception of everything we see around us. We've journeyed through unpacking its name, tracing its timeline, examining its evidence, and understanding how it connects to us. It's a cornerstone in comprehending our universe, a beacon lighting our path to knowledge. Thanks for joining this cosmic journey. Don't forget to subscribe to the channel for more fascinating insights into our universe.